So in the last class we went up to simplify the R equation. We got an R equation in terms of rho, and our R equation was d square R divided by d rho square plus 2 by rho dr by d rho minus plus minus 1 by 4 plus n by rho minus L into L plus 1 by rho square into R is equal to 0. That was our equation, that is the rho equation, okay, or R equation. And this equation is a simplified equation. Even if it is a simplified equation, to get the solution of this equation is not very easy. Getting the solution means finding out the value of R, okay. It is still not easy. So we have to have some consider some cases in order to solve this equation. And let us assume that rho is very large. That is, as the case 1, rho is very large, okay. That is the case 1. So if rho is very large, then we can check which terms are going to be negligible if rho is very large. You can see that this term, that is L into L plus 1, I hope you can see this, L into L plus 1, yeah, L into L plus 1 divided by rho square. In this term we have rho square in the denominator, okay, and since rho is very large, this term will be very small, and n by rho will also be very small because rho is in the denominator, and this term will also be very small because rho is in the denominator. So in this case we will have a simplified equation like d square R divided by d rho square minus 1 by 4 R is equal to 0, because all other terms are negligible. We can neglect that, it is avoided in the new equation. And the solution of this equation is very simple, and the solution is R is equal to A exponential minus rho divided by 2 plus B exponential rho by 2. That is the solution of this equation. But even if this is the mathematical solution of this expression as a whole is not acceptable for us, because here what we are getting is a wave function, right? We are solving the equation and R is a wave function, because that is the solution of the part of the solution of the Schrodinger wave equation that we have already created. So this wave function must be well behaved. In order for the wave function to be well behaved, it must be finite. But if rho is very large, as we assumed first, for very large value of rho, then exponential rho by 2 will tend to infinity, right? Therefore this expression, if we are using this expression, R will become infinite, because this quantity, this term will tend to infinity for very large value of rho. So we cannot include this term in our wave function as a part of the wave function. So the acceptable R is, that is an acceptable wave function, R is equal to A exponential minus rho by 2. This is the only part which is acceptable, okay. So here we have an expression for R, that is A exponential minus rho by 2. A is any coefficient, okay. We are not worried about that coefficient at this moment, and the important part of the wave function, important mathematical part of the wave function is exponential minus rho by 2, okay. And this is the case when rho is very large. And now we can consider the other case, that is case 2, that is when rho is very small, rho is very small. And when rho is very small, if rho is very small, then what will happen? If rho is appearing in the denominator, that term will be very large, because rho is very small and it is in the denominator itself. So if we are considering the terms inside this square bracket, that is minus 1 by 4 plus n by rho minus L into L plus 1 by rho square, the third term, that is L into L plus 1 by rho square, will be much greater than the second term, which will be much greater than the first term, that is 1 by 4. Okay, so we can write L into L plus 1 divided by rho square is much greater than n by rho, which is much greater than 1 by 4. So because of this, we can neglect the first and second term from this equation, because even if it is added to the third term, then nothing is going to happen, right? The third term itself is very large, and the contribution of the first and second term is very negligible. So we can neglect these two terms, the minus 1 by 4 plus n by rho. This term can be neglected. So our modified equation will be d square r divided by d rho square plus 2 by rho dr by d rho minus L into L plus 1 divided by rho square into r is equal to 0. This is our modified equation. And here we have an equation which is much simpler than the first equation, that is this equation. Okay, let us assume that the solution of this equation means r is rho raised to k, because we already know that r is a function of rho. Okay, and we assume that rho, when raised to some power k, then it will be equal to r, but we don't know what is the value of k. So we have to find out the value of k so that this equation is valid. Okay, that's what we are going to do. So let's assume that r is equal to rho raised to k. When r is equal to rho raised to k, we can find out what is dr by d rho. Dr divided by d rho, that is equal to k rho raised to k minus 1, that is dr by d rho. What is d square r divided by d rho square? D square r by d rho square is d by d rho of dr by d rho. Dr by d rho is k rho raised to k minus 1, that is equal to k into k minus 1 rho raised to k minus 2, that is d square r by d rho square. Now let's substitute for d square r by d rho square and dr by d rho and r in this equation. Okay, then we get d square r by d rho square, that is k into k minus 1 into rho raised to k minus 2 plus 2 by rho into dr by d rho. Dr by d rho is k rho raised to k minus 1, and 2 by rho into this quantity is 2k rho raised to k minus 2, because rho raised to k minus 1 divided by rho is equal to rho raised to k minus 2, and minus L into L plus 1 by rho square, L into L plus 1 by rho square into r is equal to rho raised to k. So rho raised to k by rho square is rho raised to k minus 2, that is equal to 0. It's equal to 0. So from this equation we can just expand this equation. Rho raised to k minus 2 is a common factor in all the three terms. So we will write the common factor at the end. So we have k into k minus 1 plus 2k minus L into L plus 1 the whole into rho raised to k minus 2 is equal to 0. It means that the quantity inside the bracket is 0. So we can write k square minus k plus 2k minus L square minus L, that is the expansion of the quantity inside the bracket, and that will be equal to 0. It means that k square minus k plus 2k, that is k square plus k, that minus L square minus L, that is taken to the other side of the equal sign, that then it will be L square plus L. So k square plus k is equal to L square plus L, and this equation will be valid in two cases. The first case is that k is equal to L. K is equal to L. This is one condition, k is equal to L. Let me just underline that, k is equal to L. And the second condition is that k is equal to minus of L plus 1. Okay, in these two cases this equation will be valid. So if you have any doubt, you can check. The first one is simple because it is a direct solution, because if you are substituting L for k in this equation, then k square plus k will be equal to L square plus L, and that is equal to L square plus L. So this equation is correct, or equation is valid. And what about the other one, k is equal to minus of L plus 1? If k is equal to minus of L plus 1, our equation will be like minus of L plus 1 the whole square, right? That is equal to L plus 1 the whole square itself. Minus of L plus 1 the whole square is L plus 1 the whole square as well, plus k, that is minus of L plus 1. Okay, we can find out what is the value of this one. We only took the left hand side of this one, so we can check that is equal to L square plus L. Okay, if it is equal to L square plus L, then this equation is valid for k is equal to minus of L plus 1. So L plus 1 the whole square, that is equal to L square plus 1 plus 2L, and minus of L plus 1, that is minus L minus 1, that is equal to L square plus 1 and minus 1, and they are cancelled. Plus 1 and minus 1 cancelled. What is remaining is L square plus 2L minus L, that is equal to plus L. So that is equal to L square plus L. So when k is equal to minus of L plus 1, then also the equation is valid. Okay, so it means that R can be either rho raised to L, means R can be either rho raised to L, or R can be equal to rho raised to minus of L plus 1. Okay, these two solutions are possible. These two are the mathematical solutions. But again, there is a problem. We are considering the wave functions, right? And the wave function must be well behaved. It must be finite. And if you are considering the second one, that is R is equal to rho raised to minus of L plus 1. If R is equal to rho raised to minus L plus 1, it just means that R is equal to 1 divided by rho raised to L plus 1. And since in our case rho is very small, we are considering this case rho is very small. Since rho is very small, and since it is coming in the denominator, rho raised to L plus 1 is going to be approaching the infinity, because rho itself is very small, and rho raised to L plus 1 will be very close to 0, and 1 divided by 0 is equal to infinity. So this solution is not quantum mechanically possible, and therefore our acceptable solution is R is equal to rho raised to L. That is an acceptable solution. So we have considered two cases here. The first case is rho is very large, and the second case is rho is very small, and for these two cases we have two extreme solutions. Okay, these two are not the complete solution, these are the extreme solutions, means the solution for the extreme cases of very large rho and very small rho. Okay, so we have to take these as the some indication of how the real solution of the R equation will appear. Okay, and this is not the real solution of the R. the real solution of the R should come from this original equation, and here we have some indication. It indicates that the real solution of R will contain the term exponential minus rho by 2, exponential minus rho by 2, because this was a acceptable solution. R is equal to exponential minus rho by 2. Therefore, it will have the term exponential minus rho by 2. I am not talking about A because A is the coefficient, and when we are considering R, there will be of course some coefficient as the normalization factor. Therefore, we should not worry about this coefficient. This coefficient will merge into the normalization factor, when we are determining the value of normalization factor. So we can say that the real solution of R from this equation will have a component that is exponential minus rho by 2, and the next component of the real solution of R is rho raised to L. Okay, so the solution of this equation will have these two components. So if you are considering all values of extreme, small and intermediate, all the values, then the solution R will be equal to rho raised to L. That is one component, because we established that already here. And then it will have another component, exponential minus rho by 2. That also we established from here. And it will have some other component in order to incorporate all the values of rho, because these are for the extreme values of rho, and for all the values of rho, including the intermediate values of rho, we have to include another polynomial, that is L rho. So L rho is a polynomial that we just introduced in order to accommodate all the values of rho. So if we are multiplying rho raised to L exponential minus rho by 2 with an unknown polynomial L rho, then that will be the solution R. Here we don't know what is L rho, we don't know, because we have to find out some value of L or some polynomial which fits in such a way that it is multiplied by rho raised to L and exponential minus rho by 2 should be the solution R of our modified R equation. So next task is to find out what is L rho. We have to find out what is L rho. We don't know what is that. Okay, so it is in order to find out L rho, that is not very difficult, because we will reach certain standard type of equations. So you will see that shortly. So in order to, instead of writing L rho, I will write L only in the coming sessions. So whenever you see L, it means that it is L rho. It means L is a function of rho. Okay, so let us start finding out the value of L rho. So keeping in mind that R is equal to rho raised to L rho exponential minus rho by 2, or simply writing R is equal to rho raised to L exponential minus rho by 2. I just wrote L because I don't want this equation to be much lengthier. So just I keep L. Okay, you keep always in mind that L is a function of rho. I already said that. Okay, so R is equal to this. Therefore, we can find out what is dr divided by d rho. Dr by d rho. Why I am finding dr by d rho? Because in our original equation we have dr by d rho here. So I am going to find out the value of dr by d rho from here. So dr by d rho is equal to dr by d rho is the d by d rho of rho raised to L exponential minus rho by 2. This is a function of that it's a product of three individual functions, rho raised to L and exponential minus rho by 2. Okay, so it is a product of 3. So we have to differentiate in such a way that the differential of first function, that is L rho raised to L minus 1, that is the differential of the first, into second function into third function exponential minus rho by 2, plus now the first function, that is rho raised to L, differential of the second, that is dl by d rho, exponential minus rho by 2 plus, okay, here first function into second function into x into differential of the third. Differential of the third is exponential minus rho by 2 into minus 1 by 2. So there is a minus 1 by 2 term here that I will write here itself, minus 1 by 2 rho raised to L exponential minus rho by 2. That is dr by d rho, okay, dr by d rho. So now we can find out what is d square r divided by d rho square, d square r by d rho square. So d square r by d rho square is the differential of this, okay, and there are 3 terms included here. Each term is a product of 3, therefore totally we will have 9 terms, 3 originating from each, so totally we will have 9. So let's do that. Let's do the differentiation of the first term, that is L differential of the first, that is into L minus 1 rho raised to L minus 2 into second function L differential into third function exponential minus rho by 2 plus L rho raised to L minus 1, that is the first function, differential of the second dl by d rho exponential minus rho by 2 plus first function into second function, the differential of the third, that is minus 1 by 2 L rho raised to L minus 1 exponential minus rho by 2. Okay, now we have done with the first term. Now the differential of the second term plus differential of the first, that is L rho raised to L minus 1 into dl by d rho, that is second function, exponential minus rho divided by 2 plus first function rho raised to L differential of the second, that is d square L by d rho square, third term exponential minus rho divided by 2, and the first function to second function into differential of the third, therefore we will have a minus 1 by 2 from here, minus 1 by 2 rho raised to L dl divided by d rho exponential minus rho divided by 2. Okay, we are done with the second term and now we are going for the third term. You can see the voice of my 7-month-old baby. Okay, I am taking the online class in one room and the baby is in the other room. That's why the voice is coming. I hope it will not disturb you. Okay, let's go for the differentiation of the third term, that is minus 1 by 2 into differential of the first, that is L rho raised to L minus 1 into second term into third term exponential minus rho divided by 2 and minus 1 by 2 first term rho raised to L differential of the second, that is dl by d rho, and the differential of the third, that is minus 1 by 2, that is then it will be multiplied this one, so this will become okay, we are where we are now. Okay, we are only here, the second one, minus 1 by 2 into rho raised to L dl by d rho exponential minus rho by 2. Okay, my mind was flicked because baby is crying in the other room. Okay, now we go for the last term, that is minus 1 by 2 first term, the rho raised to L, then second term L differential of the third, that is exponential minus rho by 2 into minus 1 by 2, then that minus 1 by 2 will be multiplied with this one, then it will become plus 1 by 4. Okay, plus 1 by 4 rho raised to L exponential minus rho by 2. So we have everything here. Okay, Now we have to again simplify this one. In order to simplify this one, we can see that there is an exponential minus rho by 2 in all the 9 terms. Exponential minus rho by 2. That is a common factor that we will write at the end. Okay. Then what we are going to do is that we are going to collect the terms with d square L by d rho square together, dl by d rho together, and L together. Okay. So we will get some common factors like d square L by d rho square, dl by d rho, and dl. And for all these we have exponential minus rho by 2 as a common factor that we will write at the end. First let us pick the term with the d square L by d rho square. So this is the term with the d square L by d rho square. Let me tick this because we have so many terms, and at the end we will be confused which one is not picked and which one is not. So I am going to pick this one, d square L by d rho square term. So I have that is equal to rho raised to L d square L divided by d rho square. Exponential minus rho by 2 is there, that I will not write. It is kept for the end. Okay. And is there any other d square L by d rho square terms? No, there is nothing else, and that's only one. And now let's move on to the dl by d rho terms. So dl by d rho terms are, this one is the first dl by d rho term. So let me write that. So plus L rho raised to L minus 1, and the next dl by d rho term is here, plus L rho raised to L minus 1. Okay, all these are in the bracket because all these will have dl by d rho as a common factor. And next dl by d rho term is this one. Okay, so there will be minus 1 by 2 rho raised to L from there, and the next one is where is the next one? It is here, that is minus 1 by 2 rho raised to L. So that's all. Okay, these are the dl by d rho terms, dl by d rho. And now we will move on to the next, that is L terms. Plus, let us begin a bracket again to put all the L terms together, and this is the first L term. Okay, this one, that is L into L minus 1, L into L minus 1, rho raised to L minus 2. Okay, next L term is, where is the next L term? And there was one L here, it was missed here. Okay, there was one L here, it was missed. Okay, sorry for that. So this is the next L term. So let us put that one, minus half L rho raised to L minus 1. And next L term is, next one is not here, and next one is here. Okay, that is minus half L rho raised to L minus 1, and the next L term is here, plus 1 by 4 rho raised to L, that is that L term. Okay, so we have L as the common factor of all these, into L into exponential minus rho by 2, exponential, the all multiplied by exponential minus rho divided by 2. Okay, that's it. Now again we can simplify this one. So d square r by d rho square, d square r by d rho square is equal to rho raised to L d square L by d rho square, rho raised to L d square L by d rho square, plus plus, let me write a margin here because otherwise my writing will go out of the field. Okay, just wait a second. Here also I need to have a margin, otherwise when I am writing this will go out of the field of the camera. Sorry, I could have done this earlier before starting this. I hope you will also get some intervals in between. Okay, yeah, hopefully this paper will be fine. This paper will be fine. I don't know, I don't have a paper down. Hopefully I can finish everything within this paper itself, hopefully, otherwise I will adjust somehow. Okay, we will see. So d square r by d rho square is equal to rho raised to l d square l by d rho square plus L rho raised to L minus 1 plus L rho raised to L minus 1, that is 2L rho raised to L 2L rho raised to L minus 1, 2L rho raised to L minus 1 minus half rho raised to L minus half rho raised to L, that is rho raised to L minus rho raised to L. Okay, dl by d rho multiplied by dl by d rho. Then what is remaining is this one plus L into L minus 1 rho raised to L minus 2 plus L into L minus 1 rho raised to L minus 2 minus half L rho raised to L minus 1 minus half L rho raised to L minus 1, that is minus L rho raised to L minus 1 minus L rho raised to L minus 1 plus 1 by 4 rho raised to L, 1 by 4 rho raised to L, the all multiplied with L, these are all L terms, and again everything is multiplied by exponential minus rho divided by 2. Okay, so we have d square r by d rho square, d square r by d rho square. Now what we are going to do is we are going to substitute our equation in the r equation. The r equation is d square r by d rho square plus 2 by rho dr by d rho plus minus 1 by 4 plus n by rho minus L into L plus 1 by rho square into r is equal to 0. In this equation we are going to substitute for d square r by d rho square, dr by d rho and r. Okay, we will substitute everything, then we will see how it will emerge. First, d square r by d rho square, that is this one, rho raised to L d square L divided by d rho square plus within the bracket 2L rho raised to L minus 1 minus rho raised to L multiplied by dl by d rho plus L into L minus 1 rho raised to L minus 2 minus L rho raised to L minus 1 plus 1 by 4 rho raised to L multiplied with L, then the whole multiplied with the exponential minus rho by 2. I am not going to write the exponential minus rho by 2 because in every expression that we are going to write here, okay, this is not complete. We have written only d square r by d rho square. When we are expanding all these things, all the terms, exponential minus rho by 2 will be a common factor, so that we are going to write at the end. So I'm not writing it here. Okay, next I will move on to 2 by rho into dr by d rho plus 2 by rho into dr by d rho. So what is dr by d rho? Dr by d rho is this one. So we have to multiply all these three terms in dr by d rho with 2 by rho. So when I multiplied with 2 by rho, I will get plus 2L rho raised to L minus 2, 2L rho raised to L minus 2 because this is multiplied by rho into L exponential minus rho by 2, and what we're going to write, plus again this should be multiplied by 2 by rho, then we will get 2 rho raised to L minus 1 plus 2 rho raised to L minus 1, 2 rho raised to L minus 1 dl by d rho, dl divided by d rho, and exponential minus rho by 2, okay, that we are going to write. And what is remaining, this should also be multiplied by 2 by rho, so 2 and 2 will be cancelled, so what is remaining is minus 1 into rho raised to L minus 1, so that is minus rho raised to L minus 1 L, and this term that is to be put at the end, that is 2 by rho into dr by d rho, okay, in our equation. And now what is remaining is minus 1 by 4 plus n by rho minus L into L plus 1 by rho square into r is equal to 0, okay. So we have to write this one, the last one, plus minus 1 by 4 plus n by rho minus L into L plus 1 by rho square, L plus 1 divided by rho square into r is equal to rho raised to L exponential minus rho by 2. That I am not going to write, exponential minus rho by 2. So we have written, or we have expanded the R equation by substituting for d square r by d rho square, dr by d rho, and r, and in all the terms we have exponential minus rho by 2, and that is equal to 0, because in the right hand side we have 0, so we can divide the whole equation, left hand side and right hand side, both with the exponential minus rho by 2. Then I can avoid writing exponential minus rho by 2 in the left hand side, so this will be equal to 0. I hope you understood, okay. Exponential rho by 2, exponential minus rho by 2 is a common factor in this left hand side, and the right hand side is 0. I divided both left and right hand side with exponential minus rho by 2, so I just have all these things together is equal to 0. Now I am going to simplify this further, that is rho raised to L d square L divided by d rho square plus 2L rho raised to L minus 1 minus rho raised to L into dl by d rho. But I have to include another term here, because there is another dl by d rho here. See, this is also a dl by d rho terms, so I can bring that, the coefficient of dl by d rho, what is appearing here, inside this bracket. So I will have plus rho raised to L minus 1. So rho raised to L minus 1 and all divided by dl by d rho plus, so this term I have already included, okay, this is already picked. When we are coming from here to here, you just keep in mind that it's already picked, so we have to work with the remaining ones. So plus L into L minus 1 to rho raised to L minus 2. I am going to expand all this together. L square L into L rho raised to L minus 2 minus L rho raised to L minus 2 rho raised to L minus 2 minus L rho raised to L minus 1 plus half not half, plus 1 by 4 rho raised to L, and all these are multiplied with L, okay, all these are L terms, all these are multiplied, this is also L, this is also L, this one is also L, all these are multiplied with L, So I will keep L to be written at the end, okay, plus 2L rho raised to L minus 2, 2L rho raised to L minus 2. This is already picked, and what is remaining? Minus rho raised to L minus 1, then minus 1 by 4 rho raised to L, or minus L minus 1 by 4 rho raised to L, or rho raised to L divided by 4, then n rho raised to L by rho, that is n plus n rho raised to L minus 1, rho raised to L minus 1, minus L into L plus 1 by rho square into rho raised to L, that is rho raised to L divided by rho square is rho raised to L minus 2. So rho raised to L minus 2 must be multiplied with minus L into L plus 1. So that is minus L square rho raised to L minus 2 minus L rho raised to L minus 2. The whole multiplied with L is equal to 0. Okay. So that is rho raised to L d square L divided by d rho square plus 2L rho raised to L minus 1 plus 2 rho raised to L minus 1. Rho raised to L minus 1 is a common factor in the first and the third term inside the bracket. So I can write 2L plus 2 into rho raised to L minus 1, or I can write 2 into L plus 1, 2 into L plus 1 rho raised to L minus 1 minus rho raised to L, okay, dl by d rho plus minus L square rho raised to L minus 2. Okay, there are many things like rho raised to L minus 2, rho raised to L minus 1, rho raised to L within this big bracket. So I will put together all the rho raised to L minus 2 terms together, rho raised to L minus 1 terms together, and rho raised to L terms together. So within this bracket, let me put one big bracket, and within this I will put, within the square bracket I will put all the rho raised to L minus 2 terms. So that is L square, that is the rho raised to L minus 2 term, minus L, okay, and any rho raised to L minus 2 term, that is plus 2L, and when coming here minus L square and minus L. So we have all the rho raised to L minus 2 terms here multiplied with the rho raised to L minus 2. Okay. Now I am going to pick the rho raised to L minus 1 terms. So plus rho raised to L minus 1 terms. Where are the rho raised to L minus 1 terms? First one is here, minus L. Now any other rho raised to L minus 1 term? Yeah, it is here. That is rho raised to L minus 1. Means minus 1 rho raised to L minus 1 term, anything, that is this one, plus n, any other rho raised to L minus 1 term? No. Okay, these are the rho raised to L minus 1 terms, rho raised to L minus 1. Then I have to put all the rho raised to L terms together, plus within the bracket rho raised to L terms. Which are the rho raised to L terms? This one, plus 1 by 4, plus 1 by 4, and when coming from here, that is here, minus 1 by 4, minus 1 by 4. Any other rho raised to L terms? No, no rho raised to L terms. Into rho raised to L is, and the whole multiplied with L is equal to 0. Okay. So we have again a simplified equation, because plus 1 by 4 and minus 1 by 4, plus 1 by 4 and minus 1 by 4, this will be cancelled. So this term is gone. Then L square minus L square, minus L, that is minus 2L, and plus 2L. So these all two will be cancelled. So this whole term is gone. So what is remaining is rho square d square L divided by d rho square plus 2 into L plus 1 rho raised to L minus 1 minus rho raised to L dl by d rho, okay, plus this term is gone. What is remaining is n minus L minus 1, n minus L minus 1 rho raised to L minus 1 into L is equal to 0. Okay, so what I am going to do now, this is rho raised to L, not rho square, rho raised to L. Now what I am going to do is I am going to divide this entire equation with a rho raised to L minus 1, divide by rho raised to L minus 1. So when I am going to divide the entire equation with the rho raised to L minus 1, I get rho raised to L by rho raised to L minus 1, that is rho d square L divided by d rho square plus 2 into L plus 1 rho raised to L minus 1 divided by rho raised to L minus 1 is 1 minus rho raised to L divided by rho raised to L minus 1, that is rho dl by d rho plus n minus L minus 1 rho raised to L minus 1 by rho raised to L minus 1. So that is gone into L is equal to 0. So we have a new equation here. The new equation is that rho into d square L, this is a simplified equation, rho into d square L divided by d rho square plus 2 into L plus 1 minus rho dl by d rho plus n minus L minus 1 into L is equal to 0. So this is a new equation we have here, and this equation is an equation of L, okay, the L. You remember what is L? What is L? That was a polynomial, that is a L or rho we introduced in between rho raised to L and exponential minus rho by 2 in order to accommodate the solution for all values of rho, the small, very large and intermediate values of rho. So we have a new equation in terms of L, and this, when we solve this equation, we will get the value of L. That is, the solution of this equation is L, the expression for L. And once we have the expression for L, then we have the expression for R, because R is equal to rho raised to L into exponential minus rho by 2. So our next task is to find out the value of L. Okay, so we have to solve this equation. The solution of this equation is simpler because this is in a standard form, and that we will learn in the next class.